So I've certainly alluded to it enough times about these masks, so let's finally do it. For one, we're going to need our boat, because the boat's going to help us along with this. So for the 100th time, we're going to grab the boat thing here, bring it in into this object, and we have it. But more importantly, we need to, if you type mask, we want a particle fluid mask, the only one that doesn't have its own cool icon. That's sad. So take it and have the compressed come into the particle fluid mask. So let it chew on that for a minute. It comes up with a volume and some volume on the bottom that we'll get rid of. This volume kind of looks like, if you kind of like squint your eyes a little bit, you can see it. There you go. It kind of looks like the areas, all the interesting areas of our sim. Because what is it doing? Well, first of all, we need to, as usual, take our particle separation and put it in there. So many things want that. As usual, we have some default settings that we can modify, but are looking pretty good. Velocity range should be fairly self-explanatory. Anything below 0.4, there will be no mask. Anything higher than 1 will be full mask. We're going to save these masks to disk, and then we're going to hook these up to our actual shaders and such. Now the spectrum that we have from before can actually be put into here. See, this input says ocean spectrum. Plug that in there, and this input here says collision objects. So plug that in there. What this will do is it will take any incoming masks. As we know, we created those masks from before, mask and mask, when we were switching between the two different spectrums. And this will now composite this mask into those. It will combine them. So the output of this is just the one mask that includes those incoming masks. So these will actually become the new masks that go to our shader. But let's finish setting this up. One thing that I like to do when we're dealing with volumes and stuff in the viewport especially is to say, make a light. So I'm just going to move my camera to a direction the light could be coming from. I'm going to control click distant light like that. Then just come back to my camera. And now if I'm in one of these advanced lighting modes like this, you can kind of get a more of a volumetric sense. There's actually now a shadow on it in our viewport, which is really nice and helpful to do debugging. Now we don't want this light to actually do any rendering or to contribute anything to the renders. So go to our out area over here, find our two mantra nodes, and say, you should render all the lights that you see, but not the distant light one. Same thing here. Now whenever we duplicate these mantra nodes in the future, that will carry along for the ride. But that's the thing. I do want to see it in the viewport. I don't want to see it being done in the renderer. Cool. So now that we can see that more easily, we can go back to work on our fluid mask. Now that we just had this volume, or set up this volume in a way that we can see it easier, let's use an entirely different way of visualizing the mask. Do an attribute from volume, like so. And let's have it go after the convert of our surface. So once it's back into points and polys mode, have it read the mask output from here. And I'll just have it be an attribute called mask. It's just a float, so it doesn't need to be, it's just one dimensional as opposed to a three-dimensional vector. And we haven't done this that much in this lesson, but if you click I and you click on an attribute, it will create a visualizer for us. So now we can really see what are we doing? We're making a mask that says suppress. This is a suppression mask. Do not do the displacement where these values are high. So a high value, meaning let's say 1, means full suppression. So do not do it wherever there is 1. Red is 1 here, or it's the highest value, and blue is the lowest value. If you forget, you can always right click on our visualizers here, click on the pencil next to the mask, and we can see that from blue to red. If If you want to be even more exact, you can go to min and max and 0 to 1 instead of having it figure it out itself every time. So this is actually probably better. So 0 to 1, wherever it's red, it will be fully suppressed. So this already looks pretty good, honestly, in terms of what we want. But let's see what else we got. We've got height range. Turn that on. Height range is nice because it ensures that any liquid that reaches over 0.5, well, we know that we don't want that to be displaced. If water gets that high, it must be on the move. It must be flying because of the boat. If I turn it off, it seems most of that was probably already being captured anyway, but I could see a couple of areas there getting captured by that. It's okay. So that's worthwhile. We can also turn on collision offset for the boat itself. It totally doesn't really matter because that's going to be cut. That's going to be covered up with the boat, so it doesn't seem like it matters. But I'll just turn it on anyway. I feel like we did something. So for all of those, I like to say, I mean, this already looks pretty much fine, but I like to do maximum to make sure that any of these that return, like let's say one meaningfully suppressed, that's the one that wins. So whatever the highest value of any of these criteria, that contributes to the final look of it. We also have this use bounding box thing here. Turn that on. This can be a way to knock out some of the weirder stuff around the edges here, and also potentially when we looked at this weird garbage down here on the bottom. So the bounding box, again, perhaps not a surprise to you at this point, we're going to once again get from our ocean source over here. And once again, I'm waiting for it to calculate stuff that doesn't matter. So bring that over, absolute references, center, absolute references. And now, everything is being targeted by that because the region combined is saying, oh, are you in me? Then you are all being suppressed. You know, we don't actually want that. So instead, we're just going to say this can be multiplied by that. There. So does it make a difference? It made some difference. How far is the fall off? Well, the fall off should probably be the 2 from right on over here in our flatten thing. I'm gonna press escape on that. I don't want to wait. I'm gonna choose just a manual. A lot of waiting for nodes that we don't really want to wait for. So I'm gonna say the flatten amount was 2, so I'm gonna copy that over to here and make that the fall off distance. So paste relative references and just sneak on back over to our visualizing attribute from volume area. So smooth it out a little bit more. If you wanted to really knock them out, that probably won't affect what we see too much, but you could have the fall off, for example, perhaps fall off even more. You could multiply it times 1.5 and have it knock out some more of that. Or you could even have the box itself, the size here, subtract like some amount off the sides. Something like that. This will probably be fine though, so I'm just going to leave it as it is. So let's save that. So what's happening here ultimately is it's calculating our new mask, which we're going to cache out in a moment, but it's also compositing the old mask from here, and it's passing through all of our spectrum stuff as well. And that's important because we need to associate the mask with the spectra. So let's look at the output here. So that's this there. You'll notice there's 2 masks because there's still 2 sets of spectra. So ultimately what it's saying is this mask, all of the composite mask, the mask that we just generated here, is altogether the thing that is associated with these spectra. So do these spectra as hard as you can, but suppress them based on this.